Hey guys, how's it going? Welcome to another episode of Ferris Makes Hardware. Last week, I tried to set up this risc-v formal project to see if we could formally verify our risc-v core, or at least a risc-v core as a starting point, and eventually use that to verify our own. Did not end up getting that far. It turns out trying to install all that on Windows and with MSys was a real pain in the ass. Am I dropping frames, or is that... I don't know. My CPU is busy. Anyway, I decided to give that another shot, trying to use the Windows Subsystem under Linux, or, sorry, Windows Linux Subsystem? Is that it? Windows Subsystem? Linux Subsystem in Windows. I don't remember. Anyway, thanks to Drew2 for suggesting that. I'm trying to install stuff like that. It seems to be going well. Seems to be going very well. Well, howdy guys in the chat. Garrett Kelly, Drew2. So far I'm just going down the list, and this has all worked. So I got Yosis and all the stuff that came with that. Symbiosis, Yisis 2. I don't know if I'm saying any of this right. Z3 I think I'm building right now. Windows Subsystem for Linux. Thank you, Lieutenant Colonel Lag. But yeah, this does seem to be working. I thought today we'd give this another shot, and I suspect this will work quite well. If not, we'll figure out something else to do. I probably should have done this off stream, but I just haven't really had any other time. Been working on our intro for Revision mostly. And as a lot of you guys know, I got a new job. This is my second week, and it's going, I think, very well. And that's one of the reasons I'm pretty stoked to continue working on some of this hardware stuff, primarily. And hopefully getting this formal verification stuff set up is going to help us get to a much more interesting and provably correct CPU design, which would be really good to have, so we can kind of move on to other parts of the system. I am still interested in making this by hand instead of using like an off-the-shelf core, because I'd like to have done that. So even if we're using, like existing test setups, I don't know. I still feel like we're doing this ourselves. Is it cutting out for anyone else as well? Because it looks like I'm dropping frames, but according to OBS, I'm not. It's frozen for you guys? Oh, man. I guess this is why you don't build stuff while streaming. Disuse, how's it going? I mean, I don't want to stop things from building. So I'm kind of thinking I'm just going to keep going, even if the video is frozen. Here, I'm going to do it with less cores. Let's just do 2 cores for building. Let's see if that helps. Let's bump up my priority here. Can I do that? Did that help, by the way, when I reduced the amount of cores that we're building with? I suspect it would. I did not think of that, putting that together. Hopefully I didn't ruin the recording or whatever. At least I'm not playing music again this time, right, guys? Is there any update with whether or not this helped? Yeah, I think that's totally on my end, you guys. Sorry about that. It was probably... I mean, OBS didn't report that it was dropping frames, so I didn't expect that would be an issue. But I maybe should have thought of that one. We're building with 2 cores now. Things are going slower, but that seems to be a better idea. Got a few more things to build, but actually not that many after this. I'm guessing, actually, I mean, OBS didn't report it was dropping frames. I'll check the recording after, but I wonder if it's just spitting them out. Spitting it out so irregularly that Twitch didn't like that. I hope that's the issue. We'll see. Oh, comment. Thank you so much for the sub. Really appreciate it. Extra hugs at revision. Yeah, that's pretty funny. Anyway, this Windows Subsystem for Linux thing is pretty rad, it seems. It just works. Yeah, I do, Drew, too. That probably doesn't help either. Surely does not. Oh, that's cool this you used. I don't remember what I was saying. Doesn't really matter. I just want to get this stuff installed. Because I really would not like to continue working on this CPU without some kind of tests. And I'd like to not do them myself, if possible. I mean, I can write my own tests as well, but it's just better if I don't. But yeah, super pleased that this is just working. Yeah, that's what I was saying. I was talking about my new job very briefly. I'm doing so much low-level stuff, and it's really, really enjoyable. I can't talk about exactly what I'm doing, but I can talk a little bit about it because I work for GraphCore in Oslo, and we're essentially building, or working on the rack scale application of these IPU machine learning processors, which is really, really fun. Hey, Repnop. And because of that, I'm just super stoked on this hardware stuff right now. Just use, I'm actually talking about the risc-v CPU in my Xenowing console. But yeah, definitely going to have better tests than they had then too. But the thing is, I don't have nearly the time or financial budget to work on this CPU that they did either. If I could sit around thinking about this CPU for 8 hours a day, I think I'd have a lot easier time designing it, even without a lot of tests. than I do currently. Yes, Garrett Kelly, multiplying very big matrices very fast. It's pretty fun because I don't know that much about machine learning. I actually kind of sold myself into that company as a GPU guy, which is not wrong. But it's like, I know some massively parallel stuff. You guys are just doing dot products, right? No, it's actually super exciting. And I'm really enjoying it. Really enjoying learning a lot of that stuff. And learning a lot about PCIe in particular. I'm just saying stuff I know is on the blog. But I'm excited. But I think for the Xenowing, I think if we get this formal verification stuff set up, then I would like to, again, just start building that CPU again from scratch, to be pipelined. Okay, so we made progress. We built Z3. Now we're gonna sudo make install. Rad, on to the next one. Although I don't actually know. If we need this. I assume I want one of these final ones. Probably this, if it's the latest anyway. Yeah, it definitely drew 2. And there's always that like nice beginning part of the job where, I mean, you go home every day with a headache because you're just picking up new stuff all the time. But you're kind of in the perfect position to do that because people don't have expectations yet. And it's really great. I don't actually know where I have a lot of this stuff set up right now. So I'm just going to download this file somewhere. And we're going to copy it. We'll make that dir first, won't we? I should have just extracted that instead of moved it, shouldn't I have? Oh well. Was it tar xf? I don't remember how to do this. Always forget this. xvzf, wasn't that it? You know what? We'll do it this way, actually. Okay. I should just copy this. Of course it was. I think that was the right directory, wasn't it? I think I did this right. I can just copy all this. Yay. What was I gonna do? Mount, I think I was in. And then C, yeah, MSys is where all my shit is. Ferris. Dev projects. Here we'll do this now. Making good progress. Maybe it was silly to put all this in my home directory under MSys, but that's just where I keep all my development stuff anyway. I feel like that's better than having this spread out, even if I'm just using this to install it into Linux. I think it's okay. Okay, that's probably good. Ferris installs stuff. That's what this episode's called. I'm just gonna start copying this because why not? And this we're not gonna just paste. Learn that lesson. I feel like I should be saying more stuff, but I just am not. Yeah, no kidding, Alcama. I think there's just this and then one more, and then we're done. And then we actually try it and see if it works. I have a good feeling about this. I think this will go well. And then we're looking good. I bet it's probably a hell of a lot easier to get stuff like Verilator working in this too, which I think I had to build from source to get it to work with MSys before, and I had to make some changes to the source to get it to build. I don't remember. I just remember it was a real pain in the ass. That's so true, Alcama. But if we were in the 90s, I don't think I'd be able to make my own 90s era game console at home on an FPGA. Though I would have loved to then also. Hey, McSlow. Yeah, Alcama, no kidding. It's 11-bit. I love it. Sorry, getting updates on the soundtrack for our intro. It's gonna be pretty cool. Should probably stop talking about that. But I'm pretty stoked about what we're making. I thought about working on some of that on stream today, but there just wasn't really any part where I could only or like there wasn't any part I could work on where I'm not giving a lot away. So that was frustrating. Mixos, you're gonna work on porting waves to SDL. That's awesome. I think you should join our Slack, by the way. We could be able to help you out, but our our helping people out bandwidth is a bit limited, of course, before revision. But yeah, feel free to meet us there. We're definitely gonna be there. We'd love to talk about that stuff, especially Ian. So I think that's cool. Wait, I just did make is what I did last. Okay, and then we'll do this stuff. Okay, that's easy. Home stretch, guys. Yeah, I think you shouldn't run into that many problems. There's a couple stuff that we shimmed ourselves. Like some instructions that I just did on inline assembler. Because we can't rely on the standard library, but if you're on Linux, you probably can. So that's probably okay. Yeah, I figured you were, Mixlo. What else am I thinking? Like that should be easy enough to fix just by using the standard library functions. And then there's the GSM codec stuff that we use that you'd probably have to get clever about. I actually want to do my own implementation of the GSM codec that we can shim into stuff like that. And I think that's the plan on Mac. And I'd like to do my own codec eventually, which I think because we'd be operating under different constraints, I think we can actually make something that would compress a little bit better with still a fairly simple decoder. Oh, Revision is a lot bigger than Evoke. Quite different, I think. For better or for worse. I think they're both great parties, though. Oh, I bet, Maxlow. Have you been to any other parties? Okay. I think... Whoops, probably shouldn't show that. I think we might be ready to test something. Maybe not, I don't know. So, did the installation stuff. We don't want GTK wave, we'll figure that out. OS5 tools, we'll get that later. I'll definitely want Icarus Verilog. So I'm actually going to try that. Sir. I want to see if there's a particular package with apt-get. apt list. Sudo apt list. That just lists all the boys. All right, let's see if we can do iverilog, which I think is what it would be called. This says v10 or better. This is 10.1, so let's do that. Sudo apt-get install iverilog, which we will want. Yeah, sorry if the stream is spotty. I think I fixed most of the issues, but I'm about to get a lot worse at talking too while I go through this. Actually, we'll just copy this. So I guess this gets the Pico RE32 repo. Nice, and we're gonna do this. Generated the checks. Guys, we might be looking very good here. Is this verifying a core? I think it is. I don't know what it's doing, skipping steps. I think this is a really good sign. Is this still spottier? It's got to be CPU load or something. I'm really sorry about that, guys. And annoyed about it. It's weird because OBS definitely hasn't reported any dropped frames. Okay, maybe it's just skipping steps and then it checks assumptions later. So maybe that's to run things faster or something. I don't really know. But I think this looks good. Oh, wait. I should have read this. This will run on the order of 4 hours. 60 individual checks that can all run in parallel. AG Superland. So probably waiting for this to finish is a bad idea. I mean, this is great, though, that it appears to be working. It's just going to take ages to do this. I would actually like to see if I can break this. Seems like a good idea. So let's do that. And hopefully it runs a check that actually breaks. I can find something fundamental like the interface. That should do it. Oh boy. Okay, so risc-v formal. I will say this. PQRV 32. Yeah, there's probably something in here we can break. Complete SV. Is this the test bench that it's gonna actually use? Because I mean, this looks like this top level interface. So I'm thinking, or is one of these a C? I don't know. It totally is G Superlin. Maybe I can remote into one of the servers at work. Because those are proper. I need to see something here. Core and wrapper. I'm guessing it's this though. If it's complete.sv. Yeah, totally, Garrett Kelly. It would be a short run. As long as they charge for wall clock time and not CPU time. Or like CPU hours. So what's something we could break here? Seems like a good idea. And we need to, oops. Run gen checks again. Run the checks. Wait, did I say something failed? No, that's me breaking stuff. I don't know if this actually breaks it, but it'd be fun if it did. Okay, it passed something. Maybe I need to find something better to break. Like reset. I mean, it looks like it's working, which is awesome. So one of the downsides to this, I was hoping that this would be a little faster so that we could kind of use this like TDD style. And maybe some of these simpler tests actually would work like that. So that we could get some kind of relatively fast iteration time as we start putting together the CPU. Maybe I'm being a little too hopeful for that, though. This is just passing all the things. Which is actually kind of bugging me because this should not work. Something like that should break it too. I mean, it really depends on what these tests are actually testing for. And I just don't really know. So we might be on a bit of a wild goose chase here. RFI core. Let's suggest this code. Maybe that helps. I really want to break something with reset because that's just going to be so fundamental. Last mem valid. That seems like something I could break. Instruction decoder. Look at these ASCII instruction things. This is kind of cool. Look at this. Main state machine. Did they do a state machine approach like I did? No. For all the people that told me that was a stupid design, you might still be right. Enable mul, enable div. think this is fun. So let's make some of this trigger on different edges. I'll flip some stuff. Infer some latches. Whoops. I don't think lots of people told me it was stupid design, but a lot of people point out, like, why don't you do a single core design or a single cycle design? Why don't you do this or that? And the whole thing is just like, I want to keep it as simple as possible. Look at this. We got some warnings. Maybe we had those before. I don't know. I think those are new, though. No, I was probably being a bit sensitive about it because it's my first CPU. But I think a lot of people were pointing out how strange it was to do a state machine like that. But I just didn't really know a simpler way to do it. So I'm at least happy to see that see that little bit of validation. Anyway, I don't seem to be able to get this. Oh! Look at this. Assert failed. Status failed. Do you get any other failures before this? This was instruction add channel 0, I guess is what that CH0 is. I don't actually know. We're going to do a sanity check. Was that and IC0? No, and CH0, wasn't it? Stop. No. Guys, I am not good at computers. Just wait and watch it. But yeah, it's not a great design, obviously, that kind of state machine. And Pico RV32 probably also does it in a smarter way. But I do still think that it's correct to say that at least it's a bit easier to write that way because you don't have to worry about any of the interlock between the pipelines. That's why it makes it simpler. And I think a lot of people are trying to point out to me that, like, if you just focus on each pipeline stage individually, it gets simpler. But it's all the hazards and stuff that I was trying to work around. And by work around, I mean not do. So it was just easier for me to imagine the whole thing is a state machine and build it that way. But I would still like to do a pipeline implementation, and I definitely want to add instruction and data caches. Okay, we want to watch for some failures here, which we shouldn't get this time. That looks good. I think that was one that failed, but I'll let it run a little more just in case. Maybe CH0 is check 0. I really don't know. But yeah, it might be that this kind of test suite is not going to be ideal for some kind of quick iteration. If we can actually, if we can run like individual tests, it might not be that bad, because then we can kind of just go test by test and run it individually. And then we can do more of the complex ones later, because a lot of these simpler ones I would expect would be relatively easy to get working. Okay, this is taking a while, so I'm just going to kill it. But I am pretty sure that it was this add check 0 that broke before. So I just scroll up a bunch. Okay, so it's add I check 0. But add check 0 also failed. That's great. So we were able to break this and prove that we could both run and verify that these tests actually work. Checks. Oh yeah, it's... So these are probably the individual checks. What does C do again? I think it just runs from that folder. Right, so this is just running these individual ones, isn't it? So if I did, for example, SPY... Still pretty slow. It might end up being faster to just write my own tests. Because I don't want to pay $20 an hour. I mean, that's awesome that you looked that up, G. Superland. And I don't think that's a bad price either. It's just I'd rather pay nothing. This is taking a while. Am I just running the wrong one again? Wasn't it this ad that I wanted to see? Yeah, that is the one. Okay, so here we pass. And then again, I'm just going to redo these changes. And we fail. That's actually great. So we know that this works. That's pretty cool. Hey, Mamu, says Aquar. So now I'm just kind of thinking like, yes, we have this way to formally verify the core. That's actually awesome. It looks like it's not very fast, obviously. So I'm wondering, actually... I would still like to do a pipeline CPU implementation, and the fact that we can run these individual tests is actually really useful, because, yeah, this takes a while, but maybe some of these lighter ones won't. And maybe we want to hook up our current implementation to this before I actually dive into a pipeline implementation. I'm not really sure. I think I'd have to think about it and probably explore this suite of tests a bit more. I mean, don't get me wrong, like, I was hoping these tests would run a little faster, but I definitely don't. I don't mind that it's this slow, because it is doing a lot of work to make sure that this is correct. This took a good minute and a half per iteration for one test, which is not exactly ideal. But yeah, I think I'm going to go now that we got this to work, which is awesome. Again, this is risc-v formal, which you guys should definitely check out if you're interested in any of this stuff. I think I'll go and I'll have a think about this before the next time I pick up this hardware project, which might be next week. We'll see. But I want to think about what we want to do for testing and the state of our core. Maybe next time we'll try to hook up our core to this. See how difficult that is. I don't know. I'll figure something out. Anyway, thanks guys for hanging out, and I'll see you next time.